So today we're going to be getting started talking about the flap system in the Wings Build Manual. And last video when I shared on the ailerons, a lot of people really enjoyed or let me know that they enjoyed getting to see the entire aileron system up front. So I think I'm going to do that as well for the flap system here and kind of give a quick overview before we jump into starting and each specific task that I did to complete this portion of my build. So I look forward to sharing that with you, and let's go ahead and jump into it and discuss the flap system on my Bearhawk Companion. The Bearhawk is designed to use a flap handle mounted between the floor and seat structure with 4 positions of flaps from 0 degrees through 40 degrees in 10-degree increments. The flaps are actuated when pulled, allowing a cable attached behind the pivot point to be pulled for flap extension. This cable runs under the floorboards between the seats, passes through 2 or 3 on some models of the far left pulleys under the floorboards, then up to a splitter. At the splitter, a turnbuckle is attached to the right and left flap legs for rigging purposes. Then the cable is routed to the upper corners of the fuselage where it is passed over a pulley with a cable guard on it, through the interior fabric, a fair lead, and then around a pulley mounted to the side of the structure. Here they're going to attach to the flap levers themselves on final assembly. This lever is connected to a torque tube which runs aft of the fuel tank. This torque tube has 2 springs attached to it that connect to a support pole that allows there to always be tension to retract the flap. A push rod is connected from the torque tube to the flaps, which transfers the linear motion of the cable into rotational motion about the flap's hinges. The flap is actuated by depressing the button and lowering the handle to raise the flaps and pulling the lever to extend them. Now let's take a look at actually doing this on my Bearhawk Companion. Today we're getting started on page 19 of the Wings Build Manual. After marking where the torque tube in the wing rubs against the outer rib, I removed it from the aircraft and then ended up sanding off the paint in this area so that way it moved freely. Actuator arm, there's a 3D printed tool that my buddy who printed the aileron jigs, he printed me this as well at the same time. You just slide that on, and this piece right here slides into the small cup side, and it just snaps right in there. There's a little hole that you're gonna mark and drill through. I would not drill with this thing on, primarily because my drill bit's going to eat that plastic, making this kind of oblonged and not as effective anymore. So I'm going to mark it, tap it with a punch really firmly so it can seat. And I'm going to actually start with the number 40 drill bit. It says to start with a 30, but I'm going to start with a smaller drill bit to make sure I get my pilot hole correct. Then I'm going to move it up to a 30 and go ahead and step drill that up, or enlarge that hole. You actually enlarge this, I think, to a number 27 before it's all said and done. But right now, that's all you're doing is you're marking this and drilling it out to a number 30.
I center punched out the mark on these holes because I did not want to drill through that template as I mentioned. Then I took a number 30 drill bit and very carefully, using a vise, drilled the hole out as accurately as I could. I ended up getting very close on this. I was really satisfied as the drill bit went through the far side as I did this. A drill press would have been better, but I felt fairly confident that for the size of the hole, I could very carefully just pay attention to making sure I was square in 3 axes. So I do recommend a drill press for this if you're not comfortable handling the drill, but it's not impossible to do otherwise, and the bolt ends up lining up perfectly on this when I install it on the aircraft. Once I had everything sanded, reamed, and cleaned up, then I ended up reinstalling the torque tube, which is a little bit of a hassle. It's a tight fit, especially where it was painted, so it's nice to have a second hand to help you with this. And then reinstalled these flap actuation arms on the torque tube itself. Make sure you get the orientation of this correct, so that way everything is lined up and able to receive the flap springs later on. Basically, you want those little tabs at the bottom to be facing outwards and the flat piece to be on either side of that support tube in the middle there. Then I moved on to the other side, removed its flap spring actuators and torque tube, and did the exact same thing over here. After installing the torque tube, I went and found the actuating push rod arms that connects to these little actuation tabs that are on either side of the support rod here, and those were located in my wing box. Now, a special note on these: the bolt that attaches this to the torque tube is only a 3/16 of an inch bolt, and while it's easy to install, operationally, that is amazing to me, that the entire force of a very, very large flap is transmitted through this 3/16 of an inch bolt. So it's something I plan on routinely looking at on the condition inspections, but it just amazes me that such a small bolt transmits a huge flap, force as you're extending it. So just respect the recommended speeds. Be slow as possible when you actuate those, and don't jerk on them, because that bolt is the main thing that torque is being transmitted through. So I know there is a standalone, or there will be a standalone video explaining how to read hardware, but just as a reminder, if you see something like this, it says AN3-16 with no A at the end of it, that is a drilled bolt. You only should use castle nuts with this type of bolt, and a physical cotter pin securing it. That's what this calls for. This calls for a castle nut to be installed on the push rod for the flaps. If you're using one that has the A on the end of it, you have to use a nylock or a mechanical lock washer. If you're using one that doesn't, it's a drilled head, and you need to use a castle nut, one that has the little, the castle type shape to it, and then a cotter pin through it. These did not come in the kit. They weren't in the call out. I just bought these off of Spruce to keep moving. I did note it in the document that I've kind of got going on. So hopefully, in a year from now or so from the release of this video, there will be a much more accurate build inventory list for the companions. All right, so my same buddy that 3D printed my aileron jigs that you guys saw when I was doing the aileron system, 3D printed the flap jig for me from Bearhawk's resource tab. And the way this works is you clip the bottom, or the top of the flap jig onto the wing mount bolt that goes into the fuselage. And then you have a perfect jig that's 5.8 inches, I think is the distance you're supposed to do, to align the flap handle, so that way these are equal on either side and everything is square, symmetrical, and done correctly. You can build one of these out of scrap metal, but since I have a guy who's got a 3D printer who is willing to do this, I just went ahead and had it printed up.
got page 21 out here, and I know this has happened a couple times. It's almost a little comical now. It says press the flap actuation rod into the flap's retracted position. This will place the actuation rod cross member against the rubber bumper installed in the previous step. Yeah, that's not listed anywhere on the previous 2 pages. I've double and triple checked. So what I'm about to do, and I can see from the image here that it is a 3/4 of an inch, which looks like rubber tubing that they are using. So I'm just going to run to Tractor Supply. I'm going to grab whatever the minimum quantity is. It looks like they're using maybe 4 inches or so of rubber here. Bring that back, glue it onto the rod, secure it with some safety wire, and then we will continue from there. So I'll be right back. I'm headed to Tractor Supply. Okay, I am back. I ended up having to go to more like a CarQuest type store, somewhere that would have hydraulic hoses that I could buy by the foot. Neither the local car parts store nor TSC had any. So I have my hose in hand now. It's 3/4 inch low pressure hydraulic hose. It can be really anything, but according to the pictures, it is 3/4 of an inch. Now, one thing that I did notice is I read through to the next several pages. It's later on that it's like page 23 or 4 where they actually mention that this is a specific part number hose, and that it is in a 3-inch increment. So I've got 8 inches here. I'm actually going to cut 3 off and safety wire that on. But it is in there. It's just not where it says it's supposed to be. So that just kind of needs to get moved up. So that way you can do that before you start drilling holes out and stuff. So it's there. I didn't have it in my inventory, so I just went and got some. This is heater hose. It was $3. I've got the jig hooked in now. I'm not even gonna put hardware on this. It's fixed, it's not coming off. And now we're gonna go drill the connections between the torque tube that's going down through the aft side of the wing and then hooking into the actual actuator for the flaps themselves. So we've got to get that in I think it's the retract position, because that's what this is set up for, is retract. And then drill the bottom side of those holes, cleco them, flip it over, drill the other side.
The build manual actually talks about zip tying this actuation arm in place against the bumper, which is the retracted position, while you're doing these drill outs. Honestly, I never ran into any problems. I just took my time, I was very careful, and match drilled those number 30 holes to this actuation tube and torque tube. Once I had that done, I inserted some clecos, then I fully extended it, flipping it around to where I could see the other side, and I match drilled the other side as well. Like I said, I think you have to do this on the aircraft. I don't see any way that you could effectively do this pulling it off, because you won't be able to line it up on that bumper. So just take your time, maybe start with the number 40, and once you've got a pilot hole drilled that you're satisfied with, work up to a number 30. Highly recommend some high quality drill bits here, or you're just gonna hate your life. This is steel, so it's better to go slow and let the bit bite than to run it fast. I ended up using a step bit to step this up to final size for the 3/16 bolt that will go through it, and then I used some gold clecos, so 3/16 clecos, to hold that in place while I do the other side. It seemed to work for me, so hopefully it does for you as well.
just put this one on if I can get everything to line up.
In the standalone bolt video, I mentioned this, but be very careful on a tight-fitting bolt like you see right here. In reality, I should have probably reamed this out a little bit more. When you have to screw the bolt in like this, you run the risk of destroying the cadmium plating that's on it, which is the corrosion resistance plating for that bolt. So it's best to make sure that it fits correctly. If there's any resistance, definitely don't like hit it with a hammer or anything. You could destroy the protective coating that bolt has installed on it, which would then ultimately be a problem down the road. The other one fit perfectly though, and in hindsight, I probably should have reamed that hole out a little bit better. I just didn't do it, and that would have been the best option for this.
All right, so that has that completed. I'm going to put some torque seal on that, and I think I'm going to go ahead and put the MS cotter pin in the control tube itself. I think at this point we can go ahead and do that. I'm not 100% certain. If I don't, I'm just going to make a note that I haven't yet on the build log. So that way, if it forgets to remind me to do that towards the end, when I go to rivet the wing together, I know to double check that hardware, which I'm going to make sure everything's got torque seal on it and is torqued down by that point anyways. Now, I don't have the springs yet. Like I mentioned previously, we kind of have identified that I missed an entire box when this wing shipped out. That's why most of the problems that we've seen so far on this build have happened, that there's been missing parts, missing components, and one of those missing components are the springs that help to retract these flaps that will go from this point right here up to these little round areas back here. So there'll actually be a spring retracting or pulling that flap back. So that way when I guess unseat it, it will go back into its retracted position.
These are some pretty heavy duty springs, so it looks like the flaps are very easily going to want to retract. They don't have any positive locking mechanism, if that makes any sense. So, make sure you get them oriented, I guess the correct direction, but then also make sure that when you're retracting the flaps, you don't just snatch release them. I don't think it would happen, but if you released it so fast that flap spring fell off, it would not retract the flaps. So, that's something to be aware of. Just anytime you're actuating a control surface or flaps, you want a smooth, continuous motion. You don't want to be jerky with it. And that's just what I'm pointing out here. So a couple of little areas to where it's important to do that. Now I'm buried myself in the forums looking at this flap handle, and you can see that the lower two slots have a piece on the back side that has been removed to basically make it easier to actuate those flaps. So it would release pulling backwards without having to hit the button. 30 and 40 degrees does not. Those are, 3/4 and full flaps, and they do not have that piece cut out. I have noticed on the forum that as an experimental aircraft, a lot of people are cutting this out. So I ended up marking as best I could the exact same angle type on this flap handle, and I end up going and cutting that out on a bandsaw up in our other shop. And I did that because I don't want this to lock up. The whole reason that there's issues on the forum is apparently some of these flap handles are sticking in that 30 and 40 degrees. I assume that's only on like a go around where there's dynamic air pressure pushing on the flap, wedging it in there. I don't want to be dealing with that. So I have gone ahead and modified my handle, as you'll see here in a little bit, and it does not have that set up on it. The flap handle connects between two bolts, one in the floor here that I'm cleaning out now, and then one basically right there under the flap handle itself. And I'm coming up here to clean it out or to ream it out. Both of these are 3/16 bolts, and they are secured, just using, since they don't rotate, a regular nylock washer. This will allow the flap to pivot at a much higher angle than the older model, I guess you would say, on the Bearhawks. Usually it's a lot lower than this. Apparently this is a more ergonomical position for it. That being said, you'll notice that when I do the floorboards later on, there's a pretty big gap between the two tabs on the back side there and this. So I've got to figure something out about how am I going to cover that. And that'll be a discussion for an entire another video when we get that together. The flap handle has a leg on the back side of it that offsets the cable to the left of the fuselage. And that's important because of what pulleys it will fly through as it's going down through the belly of the airplane.
Real fast, I want to thank the sponsor of today's video, which is Aero Creeper. Aero Creeper is a aviation grade, high quality creeper with adjustable positions. And they were kind enough to reach out and ask if they could send me one of their original creepers for me to use while I'm working on the Bearhawk. That's actually perfect because there are so many things that an old creeper, like the one I have been using on this build so far, just doesn't cut it, especially if it's not got an incline on it and it's not able to be lifted. And quite frankly, that one is just beat up and done, and I can tell from the quality of this creeper, it is going to last for decades for me. And just a quick thanks to Aero Creeper for not only sending me such a beautiful piece of machinery, but also to include a customized logo from my channel for the headrest. Super big shout out to them. Go visit their stuff, aerocreeper.com, and let's jump back into the flaps.
I next installed the 3 pulleys that go in the belly of the aircraft, and on the Companion this happens in 2 locations. I'm pretty sure it's 3 on the Model 5. The 2 right pulleys, if you are looking forwards, are the elevator pulleys. The far left one from the basically pilot position is the flap pulley, and it makes sense. It lines up with that offset on the flap handle itself. I strung some mason line through to tie to that just to make sure the alignment looked good. I do this multiple times, even on the triangle on the back, kind of the distributor, to where the left flap goes to the left actuation tube, the right one to the right, just to make sure I kind of had a general idea of how everything looked. And I haven't really seen or heard anything about this, but Colby mentions in his videos that this flap triangle needs to be as low as possible in the fully extended position, so that way you can get a full extension on the flaps. So here I'm just testing to make sure everything looks good, and I will actually set this significantly lower to the pulleys when I start swaging the cables. Cable swaging may be one of the most frustrating tasks I have done so far on this build, and it's not because I've never done it. As a matter of fact, this is one of the tasks I had on my OMP, my check ride for my aircraft mechanic certificate. It has just been over a decade since I have swaged any control cable. So the first handful that I did on the aircraft, I actually ended up replacing. I cut them off because they did not look correct, or they weren't swaged correctly. I know it's an experimental aircraft, and I could use other types of swaging equipment, swaging cable, but by using a certified aircraft's crimp thimbles, sleeves, swagers, and especially cable, I am confident in the safety of this flight control system. And this isn't even the ailerons, this is the flap system that we're talking about here. But definitely, your ailerons, elevator, rudder, you want to have one of the 719 cables on that. Something that's flexible, that has a proven track record in a high situation or a high safety scenario like this. After swaging one end of it, I ran it through the other side of the pulleys to attach to the front here. And I could have done this either way. I could have run from front to back or back to front. I just did it in this manner, and then made sure I had enough excess here to swage my cable. This is probably the biggest build part that requires two people. I spent several hours doing this by myself, and eventually I just went and got a cable clamp from our hardware store, kind of the C-clamp, D-clamp, whatever you want to call it, that I bolted onto the back side of these. But it was very difficult to get this set up correctly, lined up correctly. It would be significantly easier if you had a helper there that could hold the tail end of it. Just be very careful that you don't poke yourself with the wires that come off of this cable. Once you're done, you can use a piece of heat shrink to actually protect that, especially right here in the cabin area. I know that there'll be a cable attached at the aileron push-pull tube there at the bottom of its stick, as well as this flap handle. So I'm putting some heat shrink on that to protect it, but also any individual who's riding with me, they can't inadvertently, poke themselves on that. Next, I got the hardware and the shackle and attached this to the flap handle itself. So I thought I'd save some money and get a big box store cable cutter, only to find out that that cable cutter is absolutely hot garbage when it comes to cutting 719 aircraft cable. I think it's just designed to cut electrical, copper cable basically. So I share one little frustrating video here of me using it, but this is actually the only time I attempt to use this on this build. The rest of the time I cut the tails off using either a Dremel tool or just a cold chisel. The cold chisel works great if you've got a hard surface. It's a little bit safer than this Dremel tool. Like even watching this, I'm a little bit nervous about that cutoff wheel in my arm, how close it was to it. If you do this, use safety glasses, take your time, try not to keep anything that you don't want to lose in the arc of that cutoff wheel. Then again, I put some heat shrink on that and wrapped it up. The splitter has a turnbuckle attached to it using a fork at the splitter end and then an eye at the other end. I don't really know any other way of doing this, but I went ahead and just sort of put the turnbuckle in the middle of its range, hoping that that would allow me to rig the flaps at the end of this for whatever neutral position needs to be. I got it right in the intro of this video, but right here, I don't know why I wasn't paying attention, and you can see both the pulleys at the top, sort of behind the door post, have been put on backwards. The pulley should be on the outside, not on the inside of this system. This is gonna allow that cable to go from the fair lead at the top right there, through the pulley on the outside, and then into the flap, the end of the flap there, where it will connect to the actuator tube. From what I've seen, that pulley will be a little bit at an angle, and I don't like that. It's just kind of the way it is. I'm considering maybe modifying the way that that bolt is attached to make it a little bit straighter, but then it'll be at an angle when it goes to the actual actuation tube itself. So I don't really know what the best scenario is here. Obviously, these are flying with the pulleys as I've described them, not as I'm showing them right here. But that being said, I don't like the fact that it's kind of coming at an angle to that pulley.
One more note on those pulleys, they need cable guards, and I had not manufactured them as of this recording. I just do that out of a piece of 20 thousandths aluminum and then make it to where it bolts through and attaches to the airframe itself. Colby ends up having a really good video on this. If you're interested in that, go watch his video on the cables on his channel over there.
So the next video is going to be a little bit different, just quite frankly because I don't know 100% what I'm doing yet. So the next thing to do on the Bearhawk would be the auxiliary tanks, which I don't have, and then after that it's the AOA system, or the angle of attack pitot tube, the pitot-static system. While I know what I would like to do, I'm still not 100% settled on the panel for my Bearhawk. I'm going to do an overview video of what I'm debating on and what I ended up deciding on. But I'm kind of at a weird spot right now to where I'm looking for an engine. I haven't found one yet. I know lead times are pretty far out at Lycoming, but I would love to find one that I could either overhaul or partner with somebody to overhaul, as well as I would love to figure out what I would like that's going to fit my ideal mission for these avionics. I'm really toying right now with Garmin, Avidyne, and Dynon, and I'll do a complete overview on which one I decide and why down the road. Likely though, our next video will go into looking at the fuselage and some of the build tasks on it. Some relatively simple stuff right here at the beginning, but progressively we will be doing quite a bit more on the fuselage of this aircraft rather than the wings like we have done on this video. So I look forward to sharing that with you. I look forward to getting into the fuselage. I look forward to getting my wheels from Cleveland and getting those installed on the aircraft. And I will see you in the next one. Have a great day.